gentlemen here are here for us. Questions about whatever, life, engineering,
the universe,
future,
everything.
Yeah,
Monty Python.
42.
Douglas
Yeah,
Adams.
next question. Yeah.
But also,
here's a question right here. Right here. Yep. Oh,
do we have a spare microphone?
Oh, good.
I actually have a question for you, Mark. Thanks for
Oh no, this could be dangerous. Okay.
No, not really. I think you have the experience to answer them.
Okay, we'll try it out.
Okay, so you mentioned about ArchUnit, and I thought that it might be a fit for the project that I'm working on, with my work, which is a pretty large application with a lot of microservices. So my question is, how do we do that from zero, to convince the managers that it's needed and help us?
Well, so the question is, how with microservices, you've got a lot of those, how to start from zero and actually convince management to actually do these things? Well, I've got actually two answers to that, because the first one, I'm going to answer the second part of that question first. The exact same way that I would say to my management, I'm not going to run any functional tests. What would they say? No, you got to test. Well, why? Make sure the application works. But that's the functionality. What I want to test is the architecture, the structure, the things that needs to support for things like that are important to you: time to market, regulatory compliance, user satisfaction. Whatever the business case is, that's what I would use the reason for. Because let me tell you, you can do a lot of things with source code. But what you can't do with coding is increase scalability and elasticity. There are certain things that only architecture can actually improve. And so that would be kind of the question. Now, the first part of it was very interesting, because one of the limitations of those tools I showed, ArchUnit, NetArcTest, ArchUnit Net, SonarGraph, is in fact, they're really good for monolithic code bases or large services. But if I've got a lot of single-purpose functions, they can't really bridge that gap. And so it analyzes statically a code base. Now, if we're using single repo, fine, just walk every directory in there and I can analyze everything. But that's one of the limitations. No.
Sorry, Mark, that was a trick question. James had already fired all the management.
Oh, right. That was a trick question, wasn't it? Yeah, you already fired everybody, so I don't have to convince anybody but the development team. Right. Cool. Solved.
I don't think it's that simple. So, even in building architecture, which obeys the laws of physics, and as Kevin says, you can kick it. You have aesthetics, you have cost, you have engineering, you have standards, you have materials, you have construction methods, you have weather. And it's like 2 orders of magnitude more important than that in software. So, I mean, you can measure one dimension like maintainability, but to forecast an architecture that's going to deliver on maintainability, performance, usability, and all these other non-functional requirements, I think just comes from the center, from the school of hard knocks. So I mean, if you look at virtually every telecom system that's ever done, it's more or less the same. You look at every banking system that's ever done, it's more or less the same. And so I don't think you have a metrics-driven architecture to start with. And I think once you have it in place, and once you start adding stuff, these metrics can be really valuable. And this notion of testing your architecture and looking at things like coupling and cohesion, or this other word you said the other night.
Oh, yeah.
Is a really good thing. But in terms of starting from scratch, you're also being a little presumptuous. I think, if I understood your question, you're saying, okay, we're going to start with microarchitectures, how do we make the case to management? Well, if you're going to use metrics, you ought to be evaluating several alternatives. Microarchitectures, modular, process-based, and 5 others. And at least doing some Gedanken experiments, maybe building some prototypes, and doing the metrics across those. I don't think you can just say, okay, we're going to find some metrics that are going to justify the use of a a single technology X. So you really need advocates for each of several competing alternatives who are able to bring these metrics, if that's what you choose to use, to the fore and have a bake-off.
Interesting. Was your question about, when you said ground zero, were you talking about in terms of starting to do this kind of testing or a greenfield application? Oh, okay. Because the answer is much different. You're right. I thought I was misinterpreting it. Because the answer is much, much different if you're doing greenfield and saying, how do I start doing this?
Yeah. So actually building on both of these, you're trying to make a case to management. I'd first of all start with, how do I make a case to myself? Actually, why do I want to do this? Introspect a little bit, because there is no shortage of CV-driven architecture. Do I want to do microservices because I want to do microservices? Is that what the problem needs? What is the case here? How do I justify it to myself, my colleagues, and in fact, let's throw the word stakeholder in, although I'm always still thinking Buffy the Vampire Slayer. But let's throw the words, who is going to participate and benefit from this? Yeah, so in other words, it's making a case. And that pulls in your own experience. Oh, I have seen this before. It also pulls in the numbers. But the point is, you have to make a convincing case, because otherwise you do end up, it is a weakness. Again, it's a weakness of being human. There's nothing special in software of like, I want it to be like this. But you kind of need to prove it. It's a hypothesis. So there are a variety of definitions of architecture, but one of the ones I favour when I'm talking about architecture and process is one from Tom Gill. Architecture is a hypothesis to be proven by implementation and measurement. In other words, it's not necessarily a commitment. I have a belief. That's lovely that you have a belief. I have a preference. That's great that you have a preference. But how do we do that? And you need to walk in with more than one idea. The quote that I used pretty much, I mentioned it this morning, there was nothing, Emile Auguste Chartier, there is nothing more dangerous than an idea when you have only one idea. We are going to build this architecture. Why? Because it's great. Why? Because I read an InfoQ article on it. I'm not saying it's wrong, but I don't necessarily know that that's true. So walk to the table with a bunch of ideas and try and make the case for it. And start with yourself. Don't worry, if you can't make the case to yourself, you are not going to be able to make it to anybody else.
I think one of the talents of an architect is instinct. So let me give a little case as an example. How many of you are doing object-oriented programming? Really? When's the last you wrote an object? So a lot of the talk we're talking about classes. That's not object-oriented programming. Object-oriented programming was invented by Alan Kay, and the goal was to take the objects that are in the cognitive and volitive models of children and to put them into the computer. So the sign of a successful architecture is one that accurately reflects the mental structure of the student who's using the computer. And that's what object orientation is trying to do. And then Trigger Vanscott came along with Model View Controller and said, we're going to make that structure, that form, visible on the interface. Now, it turns out that one of the main reasons that interfaces are unusable is they violate this metaphor of the direct connection between how you're conceiving of the system and how it's implemented in the software, and that causes surprises. So if you start using metrics and coupling and cohesion and software engineering bullshit to carve up your architecture, rather than the human concern of letting the cognitive and volitive structures of the mind drive the architectures, you're going to build an unusable system. And the nerds will feel very good about it, and the architects will feel very good about it, and it all is going to test it, will pass all the tests. It's just that it's unusable.
Hey,
when's the last time you tried to make a flight reservation in Finnish Air? I mean, you simply can't do it.
Hey, this was my question, right? You said I have a question for Mark. Yeah.
Yeah, well done. Okay.
I thought you were going to hit me with the microphone for a second.
No, all questions are shared. We are a collective.
I know, I just had to say that. I was just kidding.
What's your poison, beer or Pepsi?
Okay, I'll have his beer.
Another question. But look. I've been in a club recently, and this thing was really fashionable. So really, yeah. So no more Gucci in the clubs.
It's
Coplien. Yeah. And you're going to win one. I mean, everyone who's having questions can go to the club then. Okay, good. Yeah, sure.
So for James, I have a question. You were saying about firing goal management. I'm curious, after that, how do you decide a person on a team that gets a raise or gets a higher compensation, or how do you do the new kind of evaluation system?
So what problem are you trying to solve?
I'm just curious how it would work in your vision. I don't have a problem.
So if you look at motivational theory, and I've looked a lot at this, if you want kind of an informal layperson introduction, there's a good book called Drive by Dan Pink. How many of you have seen Drive? Well, there's a nice video on YouTube if you want the 15-minute version. Basically, the pop, the motivation that lasts from a raise lasts about 3 months. And so finances, and in fact even promotion, are not effective motivators. If you look at what really motivates people, it's related to passion, to the feeling that I'm contributing and doing something good. So, for example, when I teach a course and I tell people you're going to solve a problem in the organization, how do you choose what problem you're going to solve next? In terms of payoff? In terms of schedule? No. What does the team have passion to do? There's a lot of research, and there's a wonderful research study that was done on 10,000 Dutch soldiers that shows this motivational factor. There are other military studies that show that soldiers will do something not because they believe in a great cause. So I mean, if we're looking at the war that's going on in Ukraine right now, the soldiers that are fighting, we think of them as fighting for some ideology. No. If you look at motivational theory, who are they fighting for? They're fighting for their fellow soldiers. And I mean, military trainers know this. So they try to create cohesion in the squadron so these people become codependent and become very, very, very close. So that's the thing that's going to enable you and empower you to actually go and do what you're going to do. So in terms of performance review, I mean, I'm also a Scrum guy. Jeff Sullivan is very, very, very negative on performance review, as I said in my opening comments here this morning. It doesn't make a difference. It takes a lot of time. It's waste. Money is not a motivator in the first place. If there is a place for management in the motivational scheme, it's giving people a path to a career that they fantasize about and supporting them as servant leaders in that career. It's not in performance review.
I love the parallel though with this because how often do you get a performance review? Once a year, sometimes twice, but usually once a year. So James got up here this afternoon and had awesome animations showing that feedback loop, that constant feedback loop within Scrum. Why don't we do that with our organization as well? Because if you're getting a performance review once a year, well, if you would have told me that during the first week of the year, I would have been a lot better. But now you're waiting a year to tell me, yeah, you need to improve on certain things. It's that constant feedback loop. I love the parallel of that, which is a good reason of saying performance reviews are a complete and utter waste.
Yeah!
What is needed though? Yeah, see? All right. Hey, wait a minute. No, we are supposed to disagree.
I know.
But rather, that constant feedback loop. That's how you make effective developers, effective teams. So yeah, that's the reason why I think performance reviews are a complete waste.
So I'm going to pick up on the 5 whys thing earlier on, which was to find loops. Yeah, why did we ended up with a performance review thing?
Oh yeah, wait, how did we get into this tangent? Yeah, it's all James' fault.
But this is the whole thing. It goes back to what problem are you trying to solve here? It's are we in this case of, so a wonderful human capacity is our ability to mimic and to copy without even realizing that we do it. Okay? This gives us things like language, it gives us civilization, it also has a downside. It gives us Facebook and it gives us a whole lot of other kind of crap fashion. But the point here is you've got kind of like, well, this miracle, why are we doing performance reviews? Because my last organisation did performance reviews, because we've always done performance reviews, because they do performance reviews. Okay, but why are you doing, is that it? You know, it's the kind of standard, we need to do agile transformation. Why? Because we need to do agile transformation. That's not you're not giving me you're not trying to sell it. So in other words, if we want to motivate our people, now we're getting a little bit somewhere, and you're using the stock answer off the shelf. We want to develop great products, and that organization happens to use performance reviews and they create great products. Are these independent or are they causal? We've got a lot of questions to ask here, and the more whiskey I have, the more questions I have.
That's right. But hey, you know what though? There are, at least in my experience, I've been in this industry for 37 years, and there are two things that I have seen that are positively motivators for people on teams, development teams. And the first is to make sure that, not always, but mostly, we're doing something really interesting. That's kind of the first one. And the second one is you're implementing a feature. You're working on a particular project or problem. Why? In other words, why am I doing this? Because too many times I have been in the position where it's like, blah, 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 no one's going to be using this feature. Blah, blah. So the point is this, to motivate people. If I know why I'm doing it and what business value that feature or function or particular part of the service or system that I am developing is providing the company, that gives me increased motivation. Because then I'm not just banging out cold gray apps at $4 an hour. No, I'm actually providing business value. That excites people. Makes a difference. I'm making a difference.
But even there's something there. But I'm going to say even intrinsic motivation. I had a very interesting experience a few years ago. I ran a workshop for a company in Turkey, in Izmir, and one of the participants came up to me towards the end of the week, and it was like a guilty confession. She said, I hope it's okay, but I'm really enjoying what we're doing. As if work should not be enjoyable. It's just, and I said, these techniques, they're there to make this fun. There's no reason that you go to work and have to disable your sense of joy and humanity. That's not what you're being paid. We pay you to suspend your humanity. Well, you better pay me a hell of a lot more.
Oh yeah.
You know, I've got a big price if it's that. But no, it's that there's a participation. And then when we start saying, well, one of the reasons people enjoy work sometimes is, it's the other people. I have stayed in a lower paid job. I remember actively choosing not to go to another one because I really liked the people I was with. And that's the point, is that goes right back to this kind of like, well, we've got a group here, we've got a cohesive group, and I like these people. We work together, we solve each other's problems. And
that's more valuable than a raise.
Yeah, and that was a very key, that for me, that was a key decider in not taking another offer that I had at the time. Now, of course, I'm speaking from a position of privilege, and I want to remind you that you're talking, up here we have 3 guys who are white, and all of us were born before humans set foot on another world. So please, take our advice with some caution. We speak from a certain position of privilege, but nonetheless, once you are within that space, once you are sufficiently rewarded, you're going to need something else, and performance reviews are not the thing that are going to deliver.
Yeah, and this is why I stand on research. So totally resonate. You said it once, and I was waiting for you to say it again and again and again. Intrinsic motivation.
Yeah.
Right.
And I'd like to just,
I know.
I'd like
You
to
so
summarize.
desperately want to ask another question, or
No, just listening to you guys, like my mind kept on going on the idea, right? So I think a lot of us here, we're implementing software for businesses that their aim is profit, right? And then you guys are saying like, you should do it for intrinsic motivation. My question is, if we take out management, how do we split that profit fairly?
Okay, let's talk about money.
Let's talk about collectives and a little bit of anarchy and
Let's talk about money on 2 fronts. Money is an interesting thing. Money is an interesting thing. You can't eat it. You can't sleep in it. You can't sleep with it. Money always stands for something else. Money in itself has no value. Is it for the great retirement house you want to build when you retire? Is it for the vacations you want to take? Is it for that great sports car? What do you value? Don't tell me money, because the money only is a token for something else. Now, that's true at the corporate level. So corporations don't value money. They value something else that goes along with that, very often power. Now, the same is true at an individual level. And one of the experiments that Pink describes is they did an experiment at MIT where they did this little exercise for students, and they gave them some rewards for some little game-like things, like throwing a basketball for a hoop and solving word puzzles and things like that. And depending on their performance, they got, they tried this with 3 levels of rewards. And so if you did so-so, you got, $1, you did so-so, you got $20, you did so-so, you got $50. And it turns out that the folks who were rewarded with the low amount, got typical performance. At the next level, a little bit better, but beyond that, it did not go up. So additional money does not cause more performance. So they said, okay, well, this is just MIT, this is students, $50 don't mean anything. So they went to Madurai, India, where $50 is a month's salary, and they repeated the experiment. This time, the people who were offered the highest rewards had the poorest performance. They become complacent. High rewards work against performance, not for it. Read the science.
All right, but how do you, okay, so I'm going to both agree and disagree with you.
Oh, this is like the Schrodinger's cat I showed earlier, okay? Yeah.
Exactly. So, many years ago, I worked with a gentleman on a team, and he at one point said, I'm simply here in IT, I'm just working for the money. And I'm like, dude, come on, there's so many other things, reasons why. But you know what his reason was? Because his passion in life was mountain climbing, technical mountain climbing, rock climbing. And being in IT allowed him the freedom, the money, and the opportunity to be able to do that. And I kind of respected that answer. So the point being that James said, money's a token for something. That money, for this friend, was extremely valuable and important because it allowed him to do something else that he was passionate about. So
that's just because that was the means of exchange. If they could have done it without money, it's not about money.
Well, but it is.
Money was the enabler, and actually, it's
money's the enabler.
Yeah, and as you're describing it, I worked with a guy called Andy. In fact, half the software developers in that company were called Andy. I don't know how I got in. I think it was pretty much a criteria. You were an honorary Andy. But Andy would come in every day. He was into paragliding. Okay, so he'd come in every day, as we said, with his airplane on his back. He'd come in with his paraglider packed with that, and he would arrive early. He would work, and then he would stand up and look outside, say, the wind conditions look pretty good, I'm going to ring the gliding school, see if it's all go. And then he would go off, and then he'd come back later in the afternoon. So he worked a kind of sandwich day, sometimes he worked a full flex day in lieu, and all the rest of it. That was exactly why he was doing that. He was a very, very competent software developer. He didn't have a passion for it, but it was a very clear connection. Sure. I do this because this company is near this wasn't even money. The company location was near the gliding school. I mean, he had a really very well-defined criteria. I need a living wage, and I need to be near where I can do paragliding. You know, there you go.
We've got another question?
Yeah, I have a question for Richard. Here I am.
Where are you? Oh, there you are.
Here I am. I wanted to ask, when should we start testing architecture? And if it's too late to start testing architecture after, let's say, almost 5 years or more of developing an application.
Yeah, so I'm so happy that you asked that question. So, because this is one of the things I wanted to mention in my talk, and I didn't have time. I looked at the clock, and I'm like, no, can't mention that. So now I get to. This is awesome. So my really good friend, Neil Ford, just finished up the second edition to Building Evolutionary Architecture. It should come out next month, next month. Anyways, what he defines in there, along with Rebecca Parsons and Patrick Quab, is a new term, fitness function-driven architecture. It's really interesting. When should I start testing architecture? When do you start testing code? Well, if you embrace TDD, you actually write the unit test first. And then, hold my beer. And then the test fails. You write it until it passes. And this is the kind of concept we can actually use in architecture as well. So the answer is as soon as it's possible. Now, the problem we have though is we don't have quantitative analysis yet. I don't know what we need to scale to. I don't know what our SLAs are for responsiveness or performance. And so in those terms, we can still write these tests, but what we do is qualitative analysis. Qualitative analysis is about the quality of something, not necessarily the number. I know whether we're doing better or worse in scalability as we're continuing to make changes, but I don't know what those numbers are. That's qualitative analysis. Once we start getting those specifications to what it should be, now I can enhance those tests to actually do quantitative analysis. And so my short answer to you is as soon as possible. And we can use both those kind of tests to actually determine, hey, are we scaling? Yeah, looks a little better than it did before. Nope, it continues to get worse. That's a good kind of test. It's good knowledge to have.
I'd say as well, if you're in a system without any kind of test, architecture, functional, or whatever, it's never too late to start. Because there's always, unless you're going to leave it as it is and nothing in the world will ever change, you can probably change that. A number of times today we talked about feedback loops. Well, you need to feedback. You need something. Quantitative or qualitative, that probing sense. In other words, when you're not sure what the numbers should be, you probe it, you try it out. In fact, I have a really simple one. Occasionally, I will, in the middle of a class, sometimes an architecture class, I will show the code for either BOGO sort or permutation sort. Now, these are not the kind of sorting algorithms you were taught at university. Permutation sort is how do you sort something? Well, you rearrange all the permutations successively until you find one that is sorted, or the one that is sorted. This has factorial time complexity. It is terrible. BOGO sort is you randomly shuffle until you hit that. Technically, it's not an algorithm because it's not guaranteed to terminate. Either way, the performance in both of these is terrible. Why do I put this up? Because sometimes people say, oh, we don't have any performance requirements. Okay, let's put that in your code. You will learn you have performance requirements. Somewhere between where you are now and BOGO sort is where you're actually, your performance requirement boundary, as it were. Oh, this becomes intolerable. At this point, it becomes too much or not enough, depending on your perspective. So the idea is, if you don't yet know the numbers, if you don't know the measures, you can still find out. And that's always going to be true. So you can probe it.
Yep. So I think there's even a danger in asking this question, though. So I kind of, 50% agree with this. But one of the things I like to teach, testing never fixes anything. Testing is a random sampling of the state of something at any given point in time. So just the fact you're doing testing is no guarantee it's going to make it better. The temptation for having put the investment into testing something is that you're going to fix that thing. But let me tell you about a friend of mine named Dave Thomas. This is OTI Dave again.
OTI Dave.
Yeah. He's filthy rich. So he's a venture capitalist. Let me tell you how he runs companies. He goes in, he has the team build a prototype of the deliverable. That's a prototype. They throw it away. All the code. Then they build the deliverable, and they throw it away. Then they build release 1, release 2, release 3, and throw it away. You see, coding is only 5% of the job. This is about thinking. And so if you see problems with this, great, and you just start over. And he starts over every third turn of the cycle. So if you need to also look at a bigger picture, and you need to understand this is not only about testing architecture, but it's about testing the revenues that your end users are getting. It's about asking, do we need to evolve to a new programming language? Do we need to evolve to a new technology? Do we need to use some new database technology? So and there are 3,721 things like this, of which testing the architecture is about 3. So it's easy to hang your hat on one or two things, like testing the architecture, or user experience testing, or quality testing, or expense, or things like that. And kind of, you know, that's the fashion of the day. The point is, this is just hard. There's no silver bullets. This is just hard work. And you need to look at systems from many, many, many perspectives. Architectural testing is one tool. It's a powerful one, but be careful not to get caught up on any one thing. And this again, this was one of the big sins of the TDD people. They ignored all the other stuff.
Right.
This is the fault of the systems testing people. They ignore all the other stuff, right?
So I disagree very strongly with you. I think that testing, in fact, does increase the quality. I think it finds issues that we wouldn't have had before. However,
those are two different things.
Right, and that's where I agree with you, is I still think, obviously, testing is important and necessary, but it's not the only thing, and I think that's what your point is.
Yep.
Yeah, exactly. You're right, we tend to hang our hat just on a few factors out of the dozens that are there for overall correctness, quality, you name it.
Well, the point I'm trying to make, Mark, is maybe I do the architectural test, and it's going to be some threshold somewhere that says, you know, this car is broken. I mean, you know, so jack up the car, take off the tires, throw away the car, put in a new car, jack it back down and put the tires back on. And what people are always trying to do is, you know, fix the tires. And because the tires are the thing to test, they never think to replace the car. So you need to step back and look at this and open the option beyond just repairing the system that's there.
Yeah.
And to think totally out of the box.
So you made a really good point about the fact, and I do this, where we start to write code. You write it, and then you delete it. I agree with this philosophy, because the first time you write a method, you're starting to learn about it. You remove that code, you write it again. Now I'm learning a little bit more about what that method should do. I'm starting to, algorithms are kind of coming through my mind. And you're right, I don't go as necessarily as 5 times, sometimes maybe, but this is a really good practice. And a lot of people, a lot of colleagues, a lot of people I work with do this. Now here's the point I want to make about that. You know what we don't do that for? Architecture. Why not?
I do.
Well, you're one person I know now. Okay, so somebody does.
did it.
Okay.
I can name you 5 clients of mine who do this.
See,
this is
but we're hesitant to do so, right? Because of irrational artifact attachment. The more time we spend on an artifact, a particular design, the less chance we're actually going to change it or abandon it. I'm writing a method. What did that take? 20 minutes, 30 minutes, maybe an hour? That's not much time investment, folks. I gotta remove that. And now I'm only spending 40 minutes because I've learned more about it. And it's the correct code. However, architecture, I may spend 2 weeks on a particular diagram. And somebody's like, yeah, no, I don't think you got it. It's like, dude, I'm not changing that. That took me 2 weeks. You know, we get attached to this, and this is an anti-pattern, the irrational artifact attachment. Hence of why, when we're starting out fresh, I like simple diagrams. I like sketches, because folks, that's all they are sketches.
So you would start with the bank being just a calculator, because all an account is you add some things to a number and you subtract things from a number.
Sure, that's all it is. It's a big
that
calculator.
is not the architecture of a banking system. The main stakeholder in the banking system,
Hang on.
main stakeholder in a banking system is the accountant. The main stakeholder in a banking system is the accountant, and the architecture of a banking system is transaction logs and audit trails.
Right, so let's go back and rewind a few minutes. There is nothing wrong with building it as a calculator. Why? Because you're going to throw it away, because you learned something. That is why that is your first step.
Okay.
There is nothing wrong with that. Right. You remember I was talking about probing. You're finding out things. We have this thing that I coined a phrase a number of years ago, decremental development. We always talk about incremental. Decremental is throwing things away, things that you do not need. Sometimes because nobody's using them. You highlighted the number of unused features. There's loads of unused features, and even within these features, there's loads of dead code paths in any code base. The percentage is actually quite shocking when you look at the stats. But I'm also talking about the idea that I learned something, and this I did this with a client. It's just like, wait a minute, that 1,000 lines just disappeared when we asked the questions, because we now have knowledge we did not have. It's an exploration. We're testing hypotheses. We're always doing that. So that's what you want to do. You want to keep the code kind of supple, and here's the clever bit. Here's the really clever bit. Software. It's supposed to be soft. The clue is in the name. Yet we make it so hard. I can't throw that away. The endowment effect is what you're referring to, also known as the IKEA effect. We give special value to things we have invested our effort in.
Right.
But there's a separation there. Now, one of the interesting things, and the psychological trick, and also a rather curious metaphor, throwaway code. You know how many people actually throw away their code? Because I've had this conversation a number of times with people. I've gone and I've said, oh, that throwaway code you showed me 2 weeks ago, could I have a look at it? Yeah, sure, here it is. Well, that wasn't thrown away. In the real world, the metaphor throwaway has a very precise meaning. Now, sometimes I do write throwaway code. I write it in a REPL, and then when I close the REPL, it is gone. I've got everything I needed, knowledge. But sometimes my throwaway code is sitting there. It's not part of a production branch, but it still exists. And that is the way that you satisfy your inner attachment. You say, it still exists somewhere, and I feel comfortable having taken it out of the code. I am throwing it away. No, you're not. You're just putting it in that cupboard that you never go and look at again. But it makes you feel good. You've met a psychological need, but guess what? The code just got a little bit better.
So in Barcelona, which is one of my, well, used to be one of my favorite cities.
Nice move.
Yes,
nice.
now.
Yeah.
I love going to Sagrada Familia. And one of the things, if you go to the basement, this links with Throwaway code. Gaudi, when he first took over the construction or the architecture of Sagrada Familia, had an image in his mind. And so what did he do? He actually built a model. The actual models are in the basement of Sagrada Familia. You can actually see his original designs. By actually visually modeling it, he was able to look at it and go, nah, it's not what I'm looking for. And so what did he do? He scrapped it. He built another model, Model 2. And now he's like, I like this, but the arches are blocking the beautiful view. And this started creating these really important architecture patterns. Now, when I'm saying building architecture patterns, these revolutionary things, until he got to Model 3. Now, my point is this. You can go downstairs at the basement of the Sagrada Familia and actually see all three models side by side. I have a picture of this. It's amazing. So the point is he threw those first two away. But what's valuable about, quote, throwing away your code, that's maybe still having it in a certain version of Git, is because now I can just saunter through history and I can actually see the transformations that happened either in my code or in my thinking. That's valuable information, everyone. That's really cool to see, how did I get here? Let me go backwards in that journey. And I can learn from that to kind of speed up this process at times. But it's really a fascinating thing about kind of keeping that, but throwing it away.
So let's actually talk about some really bad terminology that we use. I've just reminded of that one, okay?
What terminology did I use that was bad?
No, I'm going to bring it. You showed version 1. You talked about Gaudi's version 1, version 2, version 3. We have version control systems. That name is not terrible. It's not great, but it's not terrible. People have stopped calling them version control systems. They start calling them repos, source code repos, because it sounds cool. I mean, particularly if you've ever watched the 1980s cult classic Repo Man. And if you haven't, that is your homework.
Repo Man.
Yeah, right, exactly.
John Wayne, oh, no, I'm not going to see the John Wayne.
So the whole thing there is it sounds kind of cool because it's short for repository. What does repository mean? That's the place where you dump stuff. That's exactly what I was talking about. It's the place where you dump stuff. Oh, repository, that means we don't care about it. But people, we are missing an important point. There are two far better names. We are able to go back to previous versions and see what our thinking was when we first did it. What the previous version We have a time machine. Come on, is that not the coolest thing? Why are we not saying, let me just go back in the time machine to... Yeah, that's way cooler.
Hey.
Or alternatively, look, and this is my favorite geek reference, let's use the difference engine. Okay, Charles Babbage created the difference engine and the analytical engine as the first mechanical computers. One of them was built in the 19th century. Okay, it's a difference engine because that's what a version control system holds. But time machine is my preferred alternative.
I like that. Hey, but I have a question. What was the original question? I don't even remember anymore. I mean, that was a fascinating discussion, and I loved it, but I have no idea.
A real question.
Final question, I think. Let's spend 3 minutes.
Okay.
Then we can continue the conversation. Guess where? Upstairs. 11th floor.
Level 4?
After the prizes.
After the prices.
Like, why don't, because we're getting nowhere. Who wants a beer?
All right.
Go grab them, go grab them. Okay, let's have the question, drink the beer.
All right.
James, Mark, Kevlin, thanks for today's session and for inspiring a lot of geeks who are here. My question is related to new wave in IT, in development. For James, I have a question related to NFT. I already understand that you, for non-fungible tokens, you already say to us that is not, we lose time. But how about metaverse? Just one second. This
I
is
understand the
for
question,
you.
try again.
This question is about metaverse. What your vision about metaverse? The second question
is this a metaverse question?
Yes.
Metaverse.
One second. The second question is for Mark. What is our steps in architecture in order to decrease emission of carbon? And second is for Kevlin. What is metaphor for metaverse and for new wave of intelligent artificial?
I think that's 3 questions. I think that's a composite question.
And we each have 3 minutes.
I have a question for each of you.
Okay.
And you have 1 minute.
1 minute each.
Oh.
So three beers for this gentleman.
All right, so we have 1 minute. Oh, this is like a poetry slam.
Yeah.
Awesome. Okay. Do you want me to go first so you can think about...
Could you repeat the question? Are you asking about metaverse?
Metaverse.
I have no opinion.
You know, the economy of metaverse.
I mean, I've been looking at folks from his part of the country at MIT, the MIT AI Media Lab, making promises for 40 years. You know, you're going to have robots serving you coffee and things like that. And the metaverse is kind of a continuation of that. I'm not holding my breath.
Wow. All right. Fantastic. I like that question. So the closest 1 minute answer I can come to how do you get rid of Kanban with architecture, if I understand. Is that correct? Yes. Okay. So, how do I do this in 1 minute? Okay. I'm going to do a quote from our book, The Fundamentals of Software Architecture. Let me see if I can get this exact quote. I may not get it exact, but it goes like this. Developers should never take the artifacts produced by architects as the final word. Rather, implementation reveals details and refinements, and hence, it should be seen only as a first draft. My point of that quote is this. Iterative architecture is basically the best answer I can give you for reducing that inventory. This requires a tight collaboration, which a lot of times we don't have between an architect and the development team. Because we are working together, folks, to develop software solutions. We are not 2 camps. We should be 1 camp with different roles. There we go. So yes, boom.
Oh, okay, right. Okay, so what is the right metaphor for the metaverse? Oh, that's so meta. Right, okay, so here's the thing. I am of exactly the right age to have properly been influenced by cyberpunk in the 1980s. I read William Gibson, I've seen him speak, I read Bruce Sterling, I read Neil Stephenson's Snow Crash when it came out. This is not what we're having. This is not what is being promised. what we have, there's a whole load of social and commercial stuff we could say. The point is, because the metaverse does not yet exist, we don't know what the right metaphor is. We have to explore it. I made a point this morning that if you try too hard, you are likely to fail. The metaphor has to kind of come. If you're trying to create a system metaphor, which is what people have been trying to do with the metaverse, each company has a different proposition, they will likely fail. One of those might succeed, but it's more likely to be a hybrid of different approaches. We need to treat the space. If it ever happens, because I'm with you on this one, I think metaverse is actually the new fusion. Fusion is always a few years away, and always has been, and always will be. The point is that what's on offer at the moment from different companies, they each have a different way of making you think about it. They're each offering a different metaphor or analog. And I'm not saying that they're all wrong, but they're definitely not all right. And the eventual metaphor, should it ever happen, will be a mixed metaphor that emerges out of this. But also don't hold your breath, because it might never happen.
Awesome. All right.
Everyone, big round of applause from the gentlemen.
Oh, no, wait a minute, there's the Pataverse. I need to market the Pataverse. That's the one beyond the... No, sorry.